Welcome to solverfy.
This is chapter 27, problem number 78. We have a mass spectrometer. We are given a data plot, potential versus radius for the mass spectrometer. So we need to drive a connection between the two. In order to do that, let's start with the potential energy to accelerate them under the charges of potential is Q delta V. So that is going to cause increase in kinetic energy, which is 1/2 mv squared. Now, from here, also, well, we can isolate V out of here. It's going to be 2Q delta V over m square root of this. On a separate note, we know that the magnetic force equals mv squared over r. So we also have QBr over m for our velocity, which then equals 2Q delta V over m. So these two terms are equal to each other, basically. So then if we take the square of both sides, then Q squared V squared R squared over m squared is going to be equal to 2Q delta V m. M's are going to cancel. Then delta V is going to be equal to, one Q's are canceling also. It's going to be equal to Q V squared R squared over 2m. This gives us the potential in terms of the radius of curvature. Now, if we look at this equation carefully, as if delta y is our y, and then we have this term here that is basically a constant, that would be our slope. Let's call it n being our slope, okay? Then our r squared is going to be our x. So in this case, let's call this x as r squared. Then n here, n, which is the slope, is q times b squared over 2m, right? So if we are to actually compute the slope, like on Excel, like I did here on a separate file, as you can see, the slope is like 248,656. So that would be our slope. Then we could calculate the Q over M from here. But I mean, let's go back to the problem and answer part A, because we can. Now that if we plot V versus R squared, then we should get a straight line, right? So then the slope, this line with the slope, n equals QB squared over 2m, right? So from part B, if you plot the data on Excel and command it to show you the slope, then you're going to find something like 248,656, okay? Then this plot is basically going to be your, again, going back to this equation, let's isolate Q over M from there. Then it's 2n divided by b squared has to give us the Q over M, right? So let's do it on the next page. Q over M equals 2n over b squared. Let's calculate that. 2 times n, 248,656 divided by 0.25 squared of this is going to give us something like 8 times 10 to the power of 6. This is the ratio of the charge to mass, right? Which is the answer to part B. Now in part C, the potential is given as 20 kilovolts, and we're asked to calculate the speed as the ions enter the magnetic field. So we had already derived this relationship Q delta V equals 1 over 2 mv squared, right? The conservation of energy. Then V from here is going to be 2Q delta V over m, the square root of this. Then now we calculated Q over m. We know what that is. It's here. So it's going to simplify our calculation significantly. 2 times 8 times 10 to the power 6 times delta V, 20 kilovolts, right? So it's 20 times 10 to the power 3 volts. This is going to be something like 5.65 times 10 to the power of times 10 to the power of 5 meters per second. And then we are asked to calculate the in part E, we're asked to calculate the Q over m for a singly ionized particle. Then, if that's the case, for a singly ionized, let's say singly ionized, then our Q is basically E, right? For doubly ionized, the Q is basically the double. Now, Q over m for the first case, for the singly ionized one, would be equal to E over m. That would be equal to 2 potential. Remember what the equation was here. 2 times the potential difference divided by B squared R squared. Now, if you're writing this for a singly ionized one, I plugged in E. So potentials for singly ionized or doubly ionized potentials are going to be the same. B field is going to be the same. However, the radius is not going to be the same. So let's call this R prime, okay? And for doubly ionized, we're going to use 2E over m equals 2V over B squared R double prime squared. Now, on the next page, again, E over m, we have 2V B squared I prime squared, 2E over m, 2V B squared R double prime squared. Now, if we double this, it should give us this equation, right? So 2E over m, 4V over B squared R prime squared equals 2V over B squared R double prime squared. These are going to cancel. This is going to cancel this out. 2 B's are going to cancel. So from this equation, what we have is 2 over R prime squared equals 1 over R double prime squared. So that means 2 R double prime squared equals R prime squared. If we divide both sides by 2, we get R double prime equals to 1 over square root of 2 times R prime. So then we're given what R prime is. It's 21.2 centimeters divided by square root of 2. And this is going to give us 15 centimeters.